So let's take an example. Say you're Jake and you're in a college, so you have an ID card. Your ID card has all your details. Now these details can also be written in a matrix form like this. In this matrix, it has 4 rows, but it only has 1 column. Now Jake here wants to register for an event. So he goes to register, he goes to the registration counter. In the registration counter, he has to write his details in this form. And in this notepad, the details, the data, can again be written in a matrix form, something like this. And note here, in this form, it has 4 columns, but it only has 1 row. So while we have the same data, but earlier we used a different sort of arrangement, here the same data can be used in a different sort of arrangement. And this is exactly what row and column matrix is. So a matrix which has only 1 column but many number of rows, that becomes a column matrix, whereas a matrix which has only 1 row but many number of columns, that becomes a row matrix. And we also saw from this example that both of them can be interchanged because it's the same data, but it's just a different arrangement as and when the situation requires it. So let's formally define it now. Let's talk about column matrix. A column matrix. A matrix is said to be a column matrix if it only has 1 column. So let's take an example. Say we have a matrix something like this, 6, 7, 9. We can see it only has 1 column, whereas it has 3 rows. And if you want to generalize it, if you want to write it in a general form, say a column matrix A with elements that can be written like, so 6 can be written as A11, where this one stands for the row number, which is the first row. This one stands for the column number, which is the first column. So 6 is in the first row and the first column. And A is any general element of the matrix A. So 7 can be written as, in the similar way, A21 because it's second row and first column, whereas 9 can be written as A31 because it is third row and first column. What is to be noted in this is that 1 remains constant because it's a column matrix and it will only have 1 column, whereas the row number goes from 1 to 3 because it has 3 number of rows. Because the order of this matrix is simply 3 cross 1, where there's 3 rows and 1 column. Let's take another example. So let's take a matrix of functions. And we can see, again, if you have to write it in a general form, we'll write it as the first element becomes A11, which is first row and first column. The second one becomes A21 because it's second row and first column. And A is any general element of the matrix A. Again, to be noted that 1 here stays constant because it's a column matrix, whereas the row number goes from 1 to 2, where there's 2 number of rows, as the order of matrix is 2 cross 1. And so in general, if we have to write any column matrix of order m cross 1, then we use a notation something like this, where any element of matrix A will go from I1, where 1 remains constant as we saw because it's a column matrix, whereas it goes from 1 to m, where m is the number of rows. And let's, with the same understanding, look at row matrix. So a matrix is said to be a row matrix if it only has 1 row. And let's take an example. So we have 18, 6, 25. It can be seen here that's only 1 row here, whereas it has 4 columns. And if you were to write it in a general form of any matrix, say B, then the elements are going to be B11 because it has 1 row and 1 column. 6 becomes B12 because it is in the second column, while the row remains constant at 1 because it's a row matrix. 20 becomes B13, whereas 5 becomes B14 because it's in the fourth column, whereas it's only 1 row. And this is because the order of the matrix is 1 cross 4, where it is only 1 row and 4 columns. And a thing to be noted in a row matrix now is that the row number 1, it remains constant because it's a row matrix, whereas the column number, it goes from 1 to the number of columns, which is 4. To take another example, suppose we have another example called row matrix, and we can see, to convert it in a general form, we can just say that the first element is in the first row and first column, so that becomes B11, whereas the second element is in first row but second column, and because the order of the matrix is simply 1 cross 2, where it has 1 row and 2 columns, and so again to be noted, the 1 row remains constant here, whereas the column number moves from 1 to 2 because it has 2 number of columns. And to write it in a general form, in general, if B is a row matrix of order 1 cross n, then a simple notation can be written like B is equal to B1j, and the order is 1 cross n. 1 here remains constant for the row number because there's only one row, whereas j, it moves from 1 to n, and n here would be the number of columns because the columns would be moving. Now there's going to be many columns but only going to be one row. Now let's solve some examples based on this understanding. So we have examples, and let's take this as the first example. You can pause the video whenever you feel fit, get a better understanding. So let's try solving this question. In this question, we can see that there's only one column here. So that's one column, whereas it has 1 and there's 2. That's 2 rows. So this simply becomes a column matrix. Let's take another example. 3x, 2x squared. We can again count the number of columns. That's 1 and that's 2. So that's 2 columns, whereas there's only one row. And so this becomes, from our definition, a row matrix. Taking another example. In this example, this is the first column and this is the second column. So it has 2 columns, whereas this is the first row and this is the second row. So it has also 2 rows. So this neither is a row matrix nor is a column matrix, because for either of those, one of them has to be only 1. And let's take a last example now. We have 16, 24, 30 and 54. So it's seen that it has 1, 2, 3 and 4. So that's 4 columns, whereas there's only one row. And so this becomes a row matrix. So that's all for today. Thank you.